What's up, people? I want to show you my own version of an Arduino based electronic load. It's very compact and it's specifically designed for high power uses. And this one in particular I made, it basically can dissipate 20 amps, 400 watts, and at a fail-safe voltage of 37.5. And it's adjustable just with these two buttons right here. And the display unit basically gives you everything you need, such as the current initial setup, the actual current, the wattage, the resistance, also the temperature and the voltage, obviously. So this is my typical diagram, block diagram, to show you how it's conceived. I got my Nano right here that does all the controls, obviously. For the voltage and current, I'm using a typical ADC that takes the voltage divider, so you can see your voltages. And then you got the shunt. This particular shunt that I used was basically a small shunt designed for PCBs, but I'm gonna do it for like bigger shunts you can find easily on the market. The temperatures for the thermal shutdown readout, just got a typical thermistor that I just made it with a simple voltage divider. I wanted to do it with an LM35, but I figured, with a thermistor is more sensitive, so I went with that. So it just goes inside one of the analog pins, and you have your readout and your alarms as well. The output for the final state also uses a typical DAC, because you cannot control output with just a like PWM signal from Arduino. That's just stupid. The initial current setup, what I did is I took the signal from one of the voltage from one of the resistors that's hooked up to the MOSFETs for the final stage. That is basically this one right here. So I got 4 MOSFETs. I just took a signal from one of the resistors, doesn't matter which one you take it, and it just feeds into one of the analogs, and now that way you got your current initial setup. And I got 2 buttons, the increase and decrease. The reason why I wanted to go with the buttons is basically for the fine cars, because if you do with a potentiometer, basically you need one of those super fine adjustments and so forth and so on, and I don't want to do that. I just need 2 like simple buttons, and that's it. If I want it like to be like more fine or not, I'm just gonna set it up in the program. The ADC and the DAC and the display, all 3 of them uses the typical I2C, so everything is pretty standard. All kind about it. Okay, so I'm gonna show you a small diagram of the discrepancy between the current set and the actual current. Now, since the current set is just being fed directly into Arduino, it doesn't have analog to digital, you're gonna have a small marginal error, obviously. And this kind of this discrepancy is give or take from 80 milliamps to 100 milliamps, depending on the ranges that you want to work out. So in this lower part, basically I have the discrepancy of plus 80 to 100 milliamps, starting from the range of 0 to 2.5 amps. Okay, so for example, if you have to set the device to, I don't know, 500 milliamps, you're gonna see that the original setup is gonna be 0.4, because it's gonna be lower than the actual current readout. Okay, so you want to keep that in mind. From 2.4 to 5 amps, you're gonna have the setup and the actual amps being in a straight line. Okay, just a simple ramp. After 5 amps, you're gonna have the milliamps in drop. For example, if you go 6.5, okay, you set up your initial current to 6.5 amps, and you're gonna see the discrepancy between the actual amps and the setup amps. It's gonna vary from 80 to 100 milliamps. Okay, but me personally, I'm okay with that. And I'm okay with that. I mean, why is that? Because the device is specifically made for very high power uses. Okay, it's like we're talking about 20 amps, 400 watts here, so it doesn't matter this minor discrepancies. It's just it doesn't matter. And I'm gonna show you what I'm talking about in the next video.